In this video, we're going to go over circle theorem practice questions. So I have a question with me here, which is saying, in the following diagram, A, B, C, and D are points on the circumference of the circle, and center O, which is we have the center O, which is the center there, and then BD is the diameter, and then AD is equals to AC, and angle BDC is equals to 22 degrees. So I have two properties that are going to help us to solve this question. The first property says the angle opposite the center in the same circle, they make a 90 degrees. So we have two angles in the same circle that are making a 90 degrees there. So if we have a diameter, which is this diameter there, and then you have the angles, which is this angle there opposite to the diameter, also this angle which is opposite to the diameter. So we have two angles, angle A, triangle A and triangle B. So this angle which is here, it is making a 90 degrees. Also this angle which is there, it is making a 90 degrees. Do not forget this property, it is very useful. Yeah. And then also, if you have the angles that are touching the circumference of the circle, for as long as they are coming from the same chord, which simply means that those angles are the same. These angles are the angles that we are talking about. It is these ones. So we have the chord there, which is PR as our chord, and then we have angle T there touching the same chord, and also we have the angle S. Let me just use the different color there, also touching the same chord like that, which simply means that if I have a 20 there, also here I'm going to have a 20, for as long as they are coming from the same chord. Those are very important properties that anyone needs to understand. Now, coming back to the question, we need to find the angle BAC. So the angle BAC, now if you're able to see our BAC, if I can just highlight this BAC, it is this one. Now if you are able to see, we have the chord there. The chord that we are having, it is BC, like that. And then the other angle that is coming from the same chord with angle A, it is angle D. So if I can just highlight this, I'm talking about this angle which is there. I'm sure we are able to compare this from that property, which simply means that here, since we have a 22, also here we are having a 22 degrees. So our angle there is equal to 22 degrees. That is our answer. For part B, we are finding CBD like that. So come back to our diagram. We have already discovered that here it is 22 like that. So we are finding angle what? Angle we are finding angle CBD. So if I just highlight this, it looks like this: angle CBD, CBD, like that. And then remember, BD, it is our diameter. So which simply means that we need to find this angle which is here. This angle, that's the one they're asking us to find. But now, if we can complete this, if you're able to see that the triangle that we are coming up with, it is the triangle in the semicircle. If I complete this, we are having a triangle in the semicircle. Now, a triangle in the semicircle, for as long as it is touching the circumference, now the opposite angle to the diameter is making what? A 90. So, which simply means that here we are having a 90 degrees like that. And then we already have 22 degrees. Therefore, we all know that a triangle is add up to 180. Therefore, we are able to find this angle which is here. So what we can do, we can just say, we say 180 degrees, we subtract it from 90 degrees plus 22 degrees. When we add this, we subtract it from 180, and then we are going to get our answer. So if we do this, which simply means that we have 180 there minus, now 90 degrees plus 22 degrees, it is what? It is 112. So we have 112 degrees. Here also 180 is a degree. So when we subtract this, therefore here there we have a 7, here there a 10, so this is 8, and then that is 6, and then that is a 0. Therefore our answer becomes 68 degrees. If you want, you can leave it like that, or if you want, you can just say 68 degrees like that. So that is our answer. Now for the last part, here you are found to have 68 degrees, so there I have 68. Now we have to find angle what? ACO. So in order for us to find our angle ACO, what we have to do, this is also very easy. So what you can just do, you say, by the way, our ACO, let me just highlight it as well. Our ACO, A, like that, and then C, and then we have O there, which simply means that we are finding this angle which is here. Now one thing that you have to understand, that if you remember this property of saying having the diameter, so what you can just do, you say, since we are having a diameter, let me just highlight the angle that I'm trying to talk about with the property. As you can see here, BD is our diameter. There we are making an angle that is touching the circumference like that, which simply means that this angle which is opposite to the diameter, it is making a what? It is making a 90 degrees like that. And then we already have 22 there. In order for us to come up with this angle which is just there, we have to say 90 minus 22, because 90 it is the order of this, and then we have 22 just for this part. Therefore, in order for us to come up with just that part, we have to say 90 minus 22. So if I say 90 minus 22, the answer that I'm getting, it is 68. So there, like that. So I'm having 68. So you just write your 68 there as well. We have a 68 there. Now this 68 that you're having, you have to understand that our goal is to reach at this point in order for us to come up with this angle which is there. So what you have to do when you reach at this point, you say, since this line AD and AC, they are the same, therefore the angles that are being formed here, they are also the same. So what you just do, for the fact that they will be the same, what you can just do, you just say, you know that a triangle adds up to 180. So if I can just highlight the one which I'm focusing on, which simply means that I'm focusing on this part, like that, I already have my angle there, which is 68. So in order for me to come up with this angle and that angle, which simply means that I have to say 180 minus 68 in order for me to come up with those angles. And then what you just do, you just say when we say 180 minus 68, there's a 7, so I'm going to get 2, that is a 1 and a 1, so I'm going to get 112. This 112 I have to divide it by 2 because the addition of C, the angle C and angle D, they are giving me 112 because these lines are the same, AC and AD. So when I divide there, I'm going to have 54 like that. So this 54, which simply means that this angle is 54 and also this angle is 54 there. So if you have a 54 and also a 54, remember our goal is to find this angle there. So what you just have to do when you reach at this point, remember this angle is twice that angle for the fact that it is at the center and then they are coming from the same chord, which is CD. So what you do when you just say 68 plus 68, which simply means that we are going to get this angle which is here. So what you just have to do when you reach at this point, you say 68 plus 68. So when I add 8 plus 8, that is a 16, and then that is 136. So if I have 136 there, which simply means that I have 3 angles. If I can just highlight this as well, I'm going to have this angle like that. Now here I've already come up with an angle which is what? Which is 136. Now that 136, I already have a 22 there, which is there. So what I just have to do, I just have to say 136 plus 22, which simply means that I'm going to have 158. And then that 158, if I subtract it from 180, which simply means that I'm going to have there it is a 2, there it is also a 2, which simply means that I'm going to have a 22 there. Now if I have a 22 there, which simply means that all of this, it is 54, and then I already have a 22. So what I can just do, I can just say I can just say 54 minus 22. So 4 minus 2, that is a 2. 5 minus a 2, that is a 3. So my answer becomes 32. So I can just say my ACO is equals to 22 degrees like that. That is our answer for this question. Now for second question, in the diagram below, A, B, C, D, E, and F are points on the circumference of the circle. So we have FBD is equals to 70 degrees and AEF is equals to 20 degrees. Part A is saying explain why AD is the diameter. So why is AD our diameter? So here you can just define what a diameter is, and then that becomes your answer. So you can just say because AD cuts the circle into 2 equal parts, because the line AD cuts the circle into 2 equal parts. That's our answer. Now part B1 is saying we should find ACF. So if I can just write ACF, so A A C F, like that. One thing that you have to understand, that and the one thing that you are able to see, we're having a chord there, and in this chord it is also sharing this angle, which is E, like that. So if we have 20 degrees there, also here we are having a 20 degrees. So our answer there becomes 20 degrees, like that. Now we should find DEF. So our DEF, so we just have to highlight our DEF as well. So our DEF DE and F, like that. So one thing that you have to understand for this question is that this is also very easy. One thing we have to understand is that um, we can look for that property of saying if you have a diameter there and then you are able to come up with a triangle which is like that, which simply means that here we are having a 90 degrees. Now this 90 degrees, it's only for DEA, but we are looking for DEF. Therefore when we just add uh, if we just add 90 degrees plus 20 degrees, which simply means that you are going to come up with our answer, which is 110 degrees, because we are looking for all of these touching that point. And then this portion, it is only 20 degrees, and then you already have a 90 degrees there. So you just add the two and then you get your answer. So DEF is 110 degrees.